This video is a problem out of Chapter 2, Section 2. And here it is. It says, which of the following numbers are divisible by 2? Which of the following numbers are divisible by 2? Now, if you recall, in some of the earlier material that you've looked at, if the ones digit in any number is an even number, it means that that number itself, the larger number, or the number you're dealing with, is also divisible by 2. Why? Because it just is. You say, well, that's not a very good answer. Well, let me take a couple of these that I won't do all of them, but I'm going to just randomly pick a couple here that will accomplish something that I want to show you. So, and let's just pick another one. All right, so, and that's probably good enough. I just picked 3 of them out of this list. So let's go back and look at my pad if I can for a minute. All right, so I simply picked these. I simply picked these 3 values out of the list. And the point I made a moment ago is I said that if the ones digit, okay, the ones digit, so there's the ones digit, there's the ones digit. So in this particular value, 82, I have an even number, 2, in the ones digit. This one I have an odd number, 3, in the ones digit. And this one I have an odd number, 5, in the ones digit. Let me get one more number here. Just give me a second. Let me get one more number out of that stack. Yeah, I'm going to pull out 328. I'm going to pull out 328 also. I'm going to pull out 328. Okay. And let's just write it over here. I'm going to pull out 328. Okay. And so notice now, and this is the problem number here. This is the problem number from the Math Excel. So the numerical values we're dealing with are 328, 82, 123, and 615. Now, I'm going to submit to you that this one and this one can be divided by 2. This one and this one cannot be divided by 2. Now, if you think about it for a while, you say, well, there's an easy way to prove this or disprove it. One easy way to prove it or disprove it is just to simply take 2 and create a little division problem, okay, and see what you get. Now, notice what we're going to get here. Okay. Now, let me do 2 into 208, 2 into 82 here. Can you still see? Yep, I'm just looking over the screen to make sure we're visible. Okay, and then bring down the 2. Right. Okay, now, notice one significant thing that happened to me here. Remainder equals 0. Now, what do you think is going to happen when I try it over here with this one? Well, we'll try it and see. Okay, so that you're following this little division I'm doing here. Remainder equal 1. And don't let me confuse you. I'm just going to hop over here and do 2 into 615 where I've got some room over here. 2 times 3 is 6. Whoops, can't go into that. Bring down to the next number. Whoops. I get a remainder of 1 again. So please notice, in these problems where I get a remainder that is not equal to 0, it means that, in this case, 2 cannot be divided into 320 into 123 or into 615 and have a set of groups, individual groups, that each of those individual groups have 2 items in it. Well, I can have, in this case, I can have 307 groups of 2, but I'm going to have 1 left over. Here, I have 164 groups of 2, and I don't have anything left over. And similarly to those 2 problems there. So that's one way to do it, is to say, well, can I just divide into this value and get a remainder equal to 0? Now, another way to do it, which would be a little bit cumbersome, would be to simply think of having to use repeated subtraction. Repeated subtraction by 2. And I'm not going to do it. I'm just going to show you how it would look. We would say, start with 82 and subtract 2 and get 80. Subtract 2 and get 78. Subtract 2 and so forth until you got down to the very end and convinced yourself that you had some total number of groups of 2 that used all of your 82 items here. Okay? And you could do that over here, and you'd come down to the end and you'd have a certain number of groups of 2, but you'd still have one left over. So this whole idea of divisibility is a very helpful concept, because if you just think to yourself that if a number can be divided by another number, in this case 328 can be divided by 2, and I get 164 and a remainder of 0, it tells me that 2 and 164 are factors of 328. Now in this case, I will not be able to tell you that 2 is a factor of 615. Why? Because when I divide it into 615, I get an answer, but I also have a remainder that's not equal to 0. So if you can think about the fact that if you use these rules of divisibility and you get answers when you actually do the longhand division, if you get answers that have remainders of 0, that proves that the value you're looking for is a factor of that other value. Now, they didn't ask us to do this, but it won't hurt us. So let's look at these two values here, the 123 and the 615 on another sheet of paper. So I'm just going to turn the page over, and looks like I've got some ink or something on this page. All right, so the two other values, and they didn't ask us to do this, but we'll do it anyhow, were 123 and 615. Okay. Now, you remember any of those other divisibility tests? So we know 2 will not work. What about 3? Well, this one ends in 3, and this one ends in 5. So that makes me curious as to whether or not 3 will work in both of them. So let's try it now. And so here's all I'm going to do. I'm just going to use my divisibility again, and I'm going to get this. I'm kind of shortcutting this divisibility, so don't get too confused with me. So now I get that 3 times 41 is 123, and I have a remainder of 0. So yes, 3 is a factor here. What about this one? Not sure about this one. 3 times 2 is 6. Okay, and then bring down the 1. I go 0, 0, 1. Well, I'll be darned. And we get 15 here, and we get a remainder equal to 0. So both for 123 and 615, when we try to divide them by 3, we get answers that have remainders of 0. You say, are there some other values that would work? Well, so 3 worked. 3 worked. What do you think? Would 6 work? Let's jump to 6. Well, remember that little test was if you can add these together, and if the total can be divided by 6, then the value itself could be divided by 6. Is that what it said? 1 plus 2 is 3, and 3 plus 3 is 6. So we think maybe 6 will go into that one. Uh-oh, it didn't work, did it? So that must have not been the test for divisibility for the sum of the digits equaling 6, right? Wait. I remember what that one was. I remember what it was. Here's what they said. They said if the sum of the digits, what sum of the digits? What are you doing here? I'm adding these together. 1 plus 2 is 3, and 3 plus 3 is 6. If the sum of those digits, and if the ones is an even value, then it can be divided by 6. So in this case, since this is not an even value, it couldn't be divided by 6. So we kind of proved it down here. Oh, but it could be divided by 3. Why? Because the test will hold even if this is an odd number here. So 1 plus 2 is 3, plus 3 is 6. So yes, 3, and we've already proved that right here, haven't we? We proved that 3 would go in there. What about this one? 6 plus 1 is 7, plus 5 is 12, and 12 divided by 6, but this is not an even number. So nope, 6 would not be a factor. What about 3? Well, we've already proved that 3 will work. 6 plus 1 is 7, plus 5 is 12, and 12 can be divided by 3. So we've already proved that. What about 5? No. And why? Because this does not end in 5 or 0. So that's the usual test for 5. If this doesn't end in 5 or 0, meaning the one's value is 5 or 0, then it will not work. Okay, and this one, 5 will work. How can I prove that? Well, I can just come down here and just do a little division. And I get 123. With no, I'm shortcutting here on my work here, but I'm just trying to kind of review some of these little divisibility rules. Again, what good is this stuff? Well, it gives you an idea of an approach for trying to find factors, because we do in fact care about division when we want to make a certain number of groups of a certain size. But in this application, what we're more interested in is whether or not 3, 5, 6, and whatever numbers we've got, whether or not they are factors. They're factors of a larger number. Well, that was just kind of a little exercise. I hope that it wasn't too boring for you. And let's see here. I think I'll just call this video quit since we didn't do. Oh, wait a minute. You're feeling shortchanged, aren't you? Well, don't feel shortchanged. Let's do this. Which ones of these are divisible by 2? You ready? You tell me. Is 82? Yes. Is 328? Yes. Is 1230? Yes. And think about what I'm doing here. Is 164? Yes. Is 410? Yes. Is 738? Yes. Is 10,332? 10? Yes. 123? No. 41? No. 615? No. 369? No. Why no? Because in the case of 123, 41, 615, and 369, the ones place digit is not an even value. So let's hope we get it in here the way they want it. Let's check and see. You ready? Hey, we got it right. And you don't feel shortchanged, I hope.